Alright guys, we're going to learn our last gas law today. It's called the ideal gas law. And this is going to look at a combination of multiple things interacting with each other. That's pressure, volume, temperature, and moles, which is a new addition. We've worked with moles a lot this year, but we have not worked with them in terms of gas laws. So we're going to look at what that means today. So this is a big statement, but I'll break it down for you after. The volume of gas is directly proportional to the number of moles of gas and the temperature of gas, and is inversely proportional to the pressure of the gas. So what does that mean? So that means volume is directly related to the number of moles and temperature, meaning if the number of moles increases, so does the volume and temperature. Whereas volume is inversely related to pressure, which we already know. As the volume decreases, the pressure then increases. So the equation that we're going to be looking at for this one is something it's kind of has a silly name. It's called PV-nRT, or PV equals nRT. And on this next slide, I'm actually going to go over what this means. So where P stands for pressure, V stands for volume, N stands for the amount of moles, R is a constant, which means it's always given to you. It will always be this value, and then T is temperature. So let's look a little bit more at this constant, because units are going to be really important for the ideal gas law. So you'll notice that the constant, because the constant is exactly that, it's constant, the units on the constant will never change. It will always be liters per atmospheres over moles per Kelvin. Okay, which means the other units in your problem must match your constant, which means your pressure for the ideal gas law calculations must be in ATMs. Your volume must be in liters. And your amount of moles must be in moles, and your temperature must be in kelvins. So if you get a problem where volume, or say pressure, is measured in mmHgs, you will need to convert this to ATMs before you can solve the problem, based on knowing that your constant will have these units. And you want to be able to cross out all of your units. And let me show you why. So let's look at an example. So suppose you want to know the pressure of a 0.18 mole of a gas at a 1.2 liter flask, or in a 1.2 liter flask at 298 K. So I'm going to go ahead and start by filling my PV and RT variables out. I've set pressure, suppose you want to know the pressure, is equal to question mark, because that's what we're trying to find. My volume is 1.2 liters, it tells me that. My moles are 0.18. My constant is given to me, 0.0821 liters per ATM divided by moles per K. And my temperature is 298 K. Now all of these units are already in the correct units. And I'm searching for pressure, which means once I solve for this equation, my answer will already be in ATMs. So I'm going to go ahead and plug into this equation, and we rearrange this equation algebraically just like we did all the rest. In this equation, I'm solving for P. So what I need to do is eliminate V and isolate P on this side. And in order to do that, I'm going to divide both sides by V. So in this case, once I plug everything in, I'll be dividing both sides by 1.2 liters, which gives me approximately a pressure of 3.7 ATM. Okay, this is when we're going to get to the U-try. So go ahead and get out a piece of paper. You'll pause on the next slide, and this is actually the only gas law you're going to be learning tonight. So once you get to the next slide, go ahead and pause, try to complete the problem on your own, and then you'll submit that. You'll submit that on Canvas, okay? And then you have a whole bit of practice problems to do. Okay, here's the U-try. Calculate the volume occupied by 0.845 moles of nitrogen gas at a pressure of 1.37 ATM and a temperature of 315 Kelvin. Okay, we're going to move on. So here are the answers. I'm going to go ahead and plug in what I know. So what do I know? I know that I have a volume, calculate the volume, that's what I'm searching for, occupied by 0.84 moles, that's my N value, of nitrogen gas at a pressure of 1.37, that's P1, and a temperature of, or just P in this case, and a temperature of 315 K, that's my temperature. So I can go ahead and plug all those in, and I know I'm searching for volume. So here I have PV equals nRT, and in this case I need to isolate my V value because that's the one I'm missing. So both sides will get divided by my pressure, and my pressure is 1.37 atms. So this gives me a total value of 16.0 liters. And look at how all of our variables cancel out, or all of our units cancel out. This is why it's important to write units, to ensure that all of yours cancel out. All right, guys, let me know if you have any questions, and we can talk more in class. Thanks.